All right, here we go. So polar phenomenon part one. So we're taking a look at some polar graphs. This is our AP content stuff. So things we got to know for the test. All right, here we go. So looking at this one, the main focus on this lesson is going to be on circles and roses. So we're going to start with circles. They're by far the easiest, and then we'll take a look at it. The roses just come with some more details and kind of some more rules that you have to memorize. But let me start going through some of these for you. So here's what the model looks like. So it's going to be a cosine theta or a sine theta. One thing to keep in mind on these as you go through is when you start looking at things in polar form and we start thinking about coordinates and points and things like that, we know that polar form is always in our theta. One thing that's the reason this first question comes up is remember that we're used to seeing things in terms of like x and y, right? Where x is the independent variable we always plug into him, and then y is the dependent variable. He's the result. That's not the case with those, right? In this case, this is the independent. We plug in for theta, and the result is the radius, and that's kind of like what we would think of like our y value because it's r equals. So just keep that in mind. This is what we plug into. This is the result, not the way it works when you look at x and y. So that's all the first question was asking. The little thing that they got right here for you to see how these circles play out. It's kind of neat, but I'm not going to take the time to do it for the sort of the video lesson part of this. Let me get right into sort of the heart of what you need to know for this. So these guys are circles whenever you just see it as a number times cosine theta or a number times sine theta. And we looked at these late into chapter 6. We saw some things like this as well. So the main points on these are if it's cosine, I'm thinking left and right. If it's a sine graph, I'll be thinking up and down. So if it's 5 cosine theta, that simply means that my first point is a radius of 5. So 1, 2, 3, 4, 5. And then I'm going to travel 0 degrees, as it looks like right there. So we did a radius of 5 with 0 radians for the angle. For the circle, real simple, that's the end of the circle. So from the origin where we started, the pole, to here makes up the circle. My circles are never that pretty, but anyway, you get the idea. Anyway, so if it's positive cosine, it will go to the right, and that's going to make up the diameter of the circle. So keep that in mind. That's this guy. He's the diameter of your circle. If it's negative, that just means we're going to the left instead of to the right. So in this case, I'm going to go -2 at 0 radians, and that's where we're going to get the diameter for him. So we connect him to the origin, the pole, close enough, but that would be our circle. As far as some of these side questions, I'll be going through maybe a little more detail in class, but as far as similarities, we need to notice that the A value makes up the diameter. If it's cosine, we know it's going either left or right. Those are kind of the two main things to notice about these. You never know what kind of questions you'll get out of this as far as like the AP content. So some of these little extra questions in here are kind of good to look at. So this one says, what is the point farthest from the pole or the origin? Same thing. And that's what I wrote here, right? That was this part. So the 5, 0 and the -2, 0 are the farthest points away, which is what makes this the diameter. So the next part is the same thing, but with sine graphs. So as cosine goes left and right, we know sine goes up and down. So here's your model. Again, the A value is still your diameter. If it's positive, you'll go up. So we're looking at going up 4. And that gives me the highest point of my circle. So do keep in mind at this one, though, the points are a little different. This is a radius of 4, right? I want a radius of 4, but then I'm traveling pi over 2 to get there. So if I'm going to write that as a point, it would look like this. And then similarly on this one, I'm going to go down 3. All right, so there's going to be the lowest point on the graph. So we have a diameter of 3. circle looks like this. If you did want to write this as an ordered pair, you could either say I went 3 and then 3 pi over 2. So that would be a good way to look at it. You could say I went negative 3 and then pi over 2. That would be fine. But either one of those would be good ways of looking at that furthest point that we have on the graph. And that's what this last one was asking, furthest from the pole or the origin. Those would be the best responses for that. So let me flip over and keep going for you. So we're going to get into the other type of graph, and this is the one that are a little more complicated. So these are the ones I really wanted to give you a little more detail on. This one I am going to show you sort of what happens on these, just to give you a glimpse of what we're in for here as we start looking at some of these. These are the roses. You'll notice these are different, or flowers. So you'll notice that these are different because it's no longer just theta, now it's n theta. And so you're going to see what happens to this once you start multiplying your angle by other numbers. The A is still basically like our kind of like a diameter. So that part hasn't really changed. That will tell you how far out you're going. But you'll see what happens when you start throwing the n in there. Let me pull up this. So this is, I'm going to play the cosine one right now. So this is the n, right here. So that's this guy, this n is going to change numbers. So watch what happens. So these are the kind of graphs we're getting on this. I'm going to pause it right there. So if it's 0, we just get this look right here. So what happens when n is 2? Notice how many petals there are. So we got 4 petals. What about when it's 3? If I can get it there. There's 3 petals. When it's 4, there's 8 petals. When it's 5, there's 5 petals. So notice on this that when it's odd, when it's an odd number, that is the number of petals, but when it's even, it doubles. So if that's 2 theta, then we're going to have 4 petals. If it was 7 theta, well, that's odd, so it will be 7 petals. We're going to talk about the symmetry on these and where they start and all that fun stuff here. I just wanted to show you a little bit about how these graphs are going to look. So let me come back to this page. Okay. So let's jump down to these graphs. So if we were going to graph something like 5 cosine theta, as we're looking to start these, I guess let me mention this. We're going to put this into our notes, so I want these for whoever's watching this. So that A value, do remember that the A value is the length of the petal, kind of like a diameter. And the n right here helps determine the number of petals. But remember, it's different whether it's odd or even, so we got to keep that in mind. All right, let's go here. So 5 cosine 3 theta. It's odd, so there's going to be 3 of them. This is a positive cosine graph, so I know it's going to come out 5 units to the right. 1, 2, 3, 4, 5. Basically where we're getting that is, what if I plugged in 0 for theta? So if I plugged in a 0, 3 times 0 is 0, the cosine of 0 is 1, times 5 is 5. In other words, we plugged in 0 for the angle and came out with a radius of 5. So that's where we're getting that first point. So where does it go from there? So for these guys, remember there's going to be 3 petals. So this guy helped give us our first one. So where are the other 2? Within the 3 petals, they're all evenly spread out throughout the circle. So remember, the whole thing is 360 degrees. I'm going to talk in degrees for a minute because it's just easier to measure out these last couple. So if this thing is 360 degrees and there's 3 of them, let's just divide that by 3. So if we do that, we got 120 degrees. So that means that every 120 degrees, I get the next petal. So if I travel 120 degrees, I get the end of the next petal. And if I travel another 120, I get the other pedal. And then if you go another 120, you'd be right back to where you started. So these are the 3 pedals that we get for this. We're going to look in a later lesson at the order of this, but just so you know, when you do a cosine graph like this, the order actually goes like this. And I'm going to show you where this comes from later, but it starts here and it travels like this. So this is the first place that it goes, and then it goes to here, and then back to 0, to 5, back to 0, and then it finishes here. And that's actually the order that it goes in. What if it's negative? So for the -4 cosine 5 theta, again, remember that this is an odd one, so this is the number of petals. There will be 5 of them. So where does it start? Well, with cosine, we're thinking left and right. So this guy would go 5 to the right, but if it was negative, we're going to start going to the left. 1, 2, 3, 4. So that's going to make up my first petal. We know there are 5 of them. They'll be evenly spread out throughout the graph. So if I did 360 divided by 5, that's going to tell me how far to travel to get to the next petal. Alright, so we got 72. This will be a little hard on these grids because they're not like super clearly laid out for that, but it'll go something like this. So if I travel 72 degrees, so about here, we'll get that one. If I travel another 72 degrees, we're going to be about here. And then another 72. Should have put me about here. One more. Put me about here. So that's a hard angle to work with. But we know it's going to look something like this. Keep in mind, positive cosine started out to the right, negative cosine went to the left, but that's what they look. And this little process will tell you how many degrees there are between petals, so that will help you draw the remaining petals. Do keep in mind that cosine graphs are symmetric to the x-axis, but we don't really call it that in this. We call it the polar axis. So cosine graphs are symmetric to the polar axis. You could fold it across this line and the top would lay right on top of the bottom. So let me just show you one of these. We don't necessarily have to do them both. But what if it was an even number? So if it's an even number, then it doubles. So there's going to be 4 petals on this one. The rest of the process doesn't change much. It's still a positive 5, so let's go out 5. 1, 2, 3, 4, 5. It's going to be the ending of my first petal. Since there are 4 of them, I would just do 360 divided by 4. And that tells me every 90 degrees I have another petal. You probably could have figured that out without doing this little process for this one, but that's alright. So 90 degrees. Staying on my circle here. 90 degrees. 90 degrees, 90 degrees. So here we go for these guys. This is actually how they draw. It would start here and it would go like this. Come down to this one. Goes back up to this one. Goes up to this guy. Back down, and it would end right there. Is how it draws. You can't tell on Desmos because it goes so fast, but if you ever type this into a graphing calculator where they graph much slower, you actually see the order in which this occurs. It goes in a much slower process, so it's kind of neat. Anyway, so keep that in mind as far as the rules for the petals that we just talked about. You can make a note to yourself here. So if n is odd, then that's how many petals there are. But if n is even, then it doubles. As far as where is the first petal located, so we already know with the cosine graphs, I already kind of talked about that, but we'll see how that changes when we get down to the sine graph. So let me jump down to these guys. Alright, so how are these different? So if you look at the first one, the same rule applies as far as n is concerned. 3 petals, 5 petals, 4, 8. Still good to know that my radius is 5, or the end of the petal is 5. I have 3 of them. All that stuff is still true. But where would this one start? So if you plugged in a 0 for theta, well, what is the sine of 0? It would be 0. So this one actually starts here. Where's the next point going to be? So the next point that we're looking at is, where does that first petal go? It's not necessarily on an axis. So when you get to the sine graphs, they're a little tougher because they're not as obvious as cosine. Cosine always starts on the polar axis. But as far as the sine graphs are concerned, there's a little rule that we use. It's pi over 2n. So if I did pi divided by 2n, then that's how we tell where to start this graph. Kind of where's that first petal? I mean, it started here, but then where do we go from there? Where do I go to the end of the first petal? So for this one, since n is 3, so plug that in. So pi over 6 is where this guy would start. So this is our pi over 6. So let's go out 5. 1, 2, 3, 4, 5. So that's actually where the first petal goes. So that's a rule that you have to remember for the sine graphs. Cosines start on the axis, but your sine graphs start here for the first petal. Well, where are the rest of them? Do the same process that we did up above. There's 3 of them, and they're all evenly spread out. So if I did 360 divided by 3, that is 120. So if I travel 120 degrees, I'll get that guy, travel another 120, you got that one. Visually, you'll know if this is right, if it is symmetric to the y-axis. Remember, we don't really call it the y-axis, they call it the pi over 2 axis, but this guy, right? So it's going to be symmetric to this. So you'll know if I could fold this on top of itself along that axis, then I'm on the right track. So that helps. Let me just throw in one of the even ones. Otherwise, these don't change a whole lot. That one's really tough because it starts at pi over 10, which we don't really have a thing for that. So you really have to kind of ballpark how this one would look. But the symmetry really helps to kind of know what that would look like. So if you were to ballpark pi over 10, right, it's going to be somewhere in there, which means I know I have another one about there. So as I'm going through, I spread these guys out evenly for 5 petals. Remember, it's symmetric to this axis, so I know I'll be on the right track if it is. But I wanted to do one with one of the evens, just to show you the difference. We'll do a hard one. We'll go to the last one. All right, this guy's got 8 petals. So here we go. This is kind of what I was referring to with the last one. We're going to have to ballpark this because we don't really have a thing for pi over 8. So remember, these guys technically start here. Right, your basic sine graph starts at the origin. According to this, my first petal will occur at pi over 2 times 4. So that's my first petals going. I have 8 of them. Even numbers double. So there's 8 of them. So if I do 360 divided by 8, then I'm making a mark every 45 degrees. So here's where it starts at pi over 8. Again, we're going to have to kind of ballpark that. I don't know exactly where that would be. We'll call that here. So the length is 3. 1, 2, 3. So we're going to go about here. So I'm trying to make a mark every 45 degrees, and I want this to be symmetric to this axis. So as I'm ballparking this, I'm going to keep that in mind. That will help guide the graph a little bit. So we'll say this is about 45, which means it's got a mirror image over here at another 45. And this guy has a mirror image over here at another 45. So those are pretty evenly spaced out. I think we're in good shape. And then so let's just keep going on those. So another 45, that would mirror across. Another 45, 45. So it would be something like that to get our 8 petals. pretty close. So anyway, there we go. Symmetry, keep that in mind. Those are popular AP questions. So sine graphs are symmetric to the pi over 2 axis. Cosine graphs were symmetric to the polar axis. So that's something to keep in mind. On the next page, so we'll be putting in all those highlights of the notes into this box. Let me just show you, because I've already filled that out. So if you're watching this because you missed class or something, then you can kind of pause it here and copy those down. But these are all the things I talked about on the previous page that you kind of want to take note of. So such as with the circles, we know this value represents the diameter of the circle. Cosines go left and right, sines go up and down. Symmetric, right? The symmetry, polar axis symmetry versus pi over 2 axis symmetry. Most of the highlights came from the roses. There's a more detail to remember. So remember, this is the general layout. The symmetry we already talked about. This is how you figure out where the first petal is for the sine graph only. For the cosine graph, your first petal is always at 0, like on the axis, on the x-axis. And then we also talked about this as far as how many petals there are, and then the distance between petals when it looks something like that. Just to mention a couple of these so you can fill these in if you're taking your own notes. So this was just a sketch of the graph, so this was like just give it a practice. Remember, if it's a negative cosine, I know it's going to the left. There's no number here, so I know it's a circle, not a rose. So that's where we're getting this one. I do want to show you 2b. This is something we will definitely be tying together at the end of all this. We got a few lessons to go through, but at the end of all this, we're going to tie in this idea. But we're going to relate it to the original graph that you guys are used to seeing. If I just said graph this, right, on like an XY grid, how would you graph it? And we're going to relate that to this so you can see where it comes from. If you plugged in 0 into this, you would get 0, which means that's where this graph starts. If you plugged in pi over 6 into this, right, and simplified it, you get 7, which means I'm going to go 7 and then pi over 6 to get the next point on the graph. So this is where the next point came from. So it started here and went like this. That was the next point. And then where did it go from there? So we plugged in another point and got negative 7 over 2. So after it went back to 0, now we're going negative 7 at pi over 2. So negative 7 pi over 2, that means this is the next point. So far it's gone like this. It's gone to here, the maximum, back to 0, the minimum, back to 0. Guess where it's going next? Goes back to the maximum and back to 0. So that's like the order in which these go in. This is my little arrow path over here. But we'll get into more of that at the end of the week. And then just a couple last things I filled in. This is just things to remember, like how many petals there are, the symmetry, angle between petals, the length of the petals, how do you know where the first petal begins, the range of a graph. So keep in mind on this one, let's mention this because we didn't talk about this yet. What would be the range of this? So remember, kind of like what you saw on this one, when my A value was 7, it sort of like saw this is my max and this is my minimum. Similar would happen on this guy. So my range on this is going to bounce between 5 and negative 5 as we trace our way through the graph. So that's where this came from. So that's it for the first one.